Deetan,
What's up?
how are you, man?
It's been a while.
It's been like ridiculous amounts of time.
Yeah, well, for good reason.
Yes.
6.4, finally out the door. It
Rock
kind of
and roll.
rhymes, 6.4 out the door.
Yeah.
Yeah.
And a new version of Mesh.
New version of Mesh coming alongside it because of it, with lots of new things. Specifically, one new thing that we're really excited to talk about today.
Excellent.
Because we've got with us one of our teammates from Serbia, Nikola.
Hey, man.
Hi.
Introduce yourself.
Hi, I'm Nikola. I'm from the Serbia part of Service Fabric team. I've been around for a while, I think like 5 years maybe even more, not so sure. I work in mostly in the area of placement and load balancing. There was one previous video where Young actually very nicely explained what is it about. And recently I've also worked with my teammates from Serbia on things like autoscaling, resource monitoring, resource governance, and similar.
So autoscaling is actually one of the things that came out for Service Fabric over the summer, but with this latest release, we've also brought it to Mesh. We've also got our teammate Vlad. Shout out to Vlad if you want to swivel the camera and give him a quick
Yeah,
one.
well, then I'd have to, might have to see me.
Give him a surprise.
Okay.
And there he is. Cool. So him and Nikola work out of the Serbia team with us.
Okay.
And so I want to start off the conversation with Autoscale mostly because it's been something that people have been looking forward to using, and now they can in Service Fabric clusters as well as in Mesh. We demoed this at Ignite, and you can see that in the talk that I did with Chaco.
Cool.
But you can actually now use it within a specific scope that we'll also discuss. But with that, I want to kick it off to you, so you can tell us a little bit more about Autoscale and why it's real, unlike Mr. Charles, who is dubious about our implementation.
So, autoscaling, as you said, is something that we added very recently. I think starting 6.3 we have support for standalone autoscaling, and it is a real thing, right? So what we do is we are going to actually monitor the load either on the metrics that you define and report. Like, I don't know, if you have some kind of gateway, you can report to us the number of incoming connections or any disk size or anything that you would like, right? Then you can tell us if the average load goes above some threshold, add one more instance. If it goes below, remove one of existing instances. And on top of that, what we did is we also added one more service to our system called the Resource Monitoring Service. And if you use that one, you don't actually even need to define the metrics, and you don't need to report the load. So what we're gonna do is we're gonna go and look at the usage of your either service or a container. It doesn't matter if it's Windows or Linux, everything basically works. And we're gonna report it to our load balancer, to PLB, and then we're gonna scale based on that.
Okay.
Right, so that would be the basic concepts.
So one question I have immediately is DDoS, right? So you're looking at your gateways getting flooded with an unusually large amount of traffic. What do you do sort of algorithmically to decide whether or not that's a DDoS attack or valid traffic? Is that something, because you're saying it's like the user doesn't have to do anything. I just say turn resource monitoring on, and then when lots of traffic comes to my exciting service, you guys are going to scale me up and then scale me back down when people go away. So my question is the DDoS one, because I'm actually been thinking about how do you actually detect DDoS versus real?
Detection of DDoS is currently not implemented or supported, right? So what we're going to do is we're going to monitor your CPU usage. If it spikes, we're going to scale you out. And the way to protect against DDoS in this case would be to actually put the maximum amount of instances that you want, because that's also supported. You can say no more than 5, whatever happens.
Okay.
So that we don't go wild and launch 1,000. That's the only protection against DDoS that we offer at this moment.
Okay.
So, and one thing I want to ask you is, autoscaling it has a really nice value proposition in the mesh world, where things are fully managed and serverless, and you can think in terms of instances of services. But when you think about a traditional Service Fabric cluster, you're already limited in some sense by the number of machines you have. And we're talking about autoscaling here from a service perspective, not a cluster perspective. So when would you expect somebody to want to use autoscaling? If I'm already defined to have like a 10 node cluster, it's not like I'm adding new nodes or removing nodes. I just have a couple of services on them. What's the use case for me? Why not just always be running at the maximum number of instances or replicas for my service? So what am I thinking about here? What should be the criteria I use to decide whether or not I need autoscaling in my cluster?
So that actually depends on your workload.
Okay.
If it's good enough for you to put everything, like same service, on 10 nodes, then that's most likely enough, right? You don't need autoscaling. You can scale manually by adding one node from the cluster to the cluster or removing a node from the cluster. But then, if you have more than one service type, and especially if they are resource hungry and they cannot coexist on the same node, then you need to get into the business of having multiple node types, managing multiple node types, looking at multiple node types in the cluster, and that's not so easy to do, right? Instead, with autoscaling, you could have something like 50 nodes of one type, and then you put all your services on them. You put resource governance as well to make sure that they don't kill each other while competing for resources.
Sure.
And you put minimums and maximums for autoscale.
I think part of this is also the density argument,
Yes.
right? Which is instead of then having to optimize for your worst case scenario at all times, which is, for example, we've got one of our customers is a electronic medical records company, right? So these guys deal with a large amount of traffic between 9 a.m. and 5 p.m. So 9 a.m. Eastern, 5 p.m. Pacific, because it's across the country. So effectively the node count has to go up every morning and come back down. But along with their node count going up, their services also must be going up. And when the services go up, you may not want every service on every node. So I guess you could use this to say, I am utilizing my available GB and available CPU to the maximum, allocating it to a secondary service when a primary service doesn't need it, and then only having the primary one because of autoscaling or something like that.
Something like that you
Yeah.
could do, yeah.
Yeah.
So,
So do you want to talk to us a little bit about how it's implemented? We'd love to see it.
yeah, why not?
Great.
So, basically, so let's start off with the most basic implementation, right? So,
And this guy's tall here for context.
He's really tall.
This is me, and that's
Hey!
him. And I'm relatively tall. I mean, I'm taller than you are, Charles. And then
No, you're taller than I am? Yeah, another fairy tales.
no,
Okay.
you're there. So let's start with a very simple case.
Okay.
Right? And the simple case is no resources involved. So let's say that you're building kind of, I don't know, gateway service. And when you're defining your gateway service, one thing that you will do is you will say that it has a metric which is called number of connections. And the default value for this metric is 0. Okay, so when it spins up, no connections. Then, from the user perspective, what you also do is you add auto-scaling policy. And we implemented it in a way that every auto-scaling policy consists of a trigger and of a mechanism, right? So you will say that this policy has average load trigger with a lower threshold of, let's say, 10 connections and upper threshold of 50 connections here, and evaluation interval of, let's say, 60 seconds. This means basically if my that we will look at every 60 seconds at the average load of all your instances, and if the average load is below 10, we initiate scale down, and if it's above 50, we initiate scale up. Okay? And how we do that is we do that by actually applying the mechanism that you give us. So let's say that this is stateless single partition service, right?
Sure.
And then you can tell us that the mechanism is add remove instance. Okay.
Okay.
and that every time when either scale up or scale down is invoked, the increment is 1, which means either add one instance or remove one instance when you do the scaling operation. That we also do have a maximum, which would say like, I don't want to have ever more than 10 instances.
Well, in this case, maybe
partition,
like, okay, cool.
right, whatever.
Which could be your node count, right, in the case of a single...
Oh yeah, can be also -1, which practically means unlimited, and in this case, node count.
Right.
Okay, this is a good point. And a minimum, let's say, never less than 1. Okay.
Okay.
So then what happens once you create this service? Say you create it with one partition to begin with one partition with one instance to begin with, and this service will get placed to a node.
Okay.
Okay, so if this is the node where the service is placed, we're going to spin up a replica here, and while it is running, it's actually your duty to monitor the number of incoming connections. And when you see a change, let's say every 30 seconds, 60 seconds, depends on your logic, you make a load report. So you say, for example, number of connections with the value of 20 is my new node.
Okay.
Okay? This eventually gets propagated by a network to our load balancer,
Okay.
PLB, and this is where we store the load report. Okay, so this is where it gets stored. Now, inside PLB, we have one very small component, which is called Autoscaler.
Okay.
And if you actually want to check out the source code,
Yes.
source code is located in, let me write it here, is located in folder production / source / reliability.
I like that he knows this off the top of his head. It's good. It means you actually did something there.
Yeah,
Yeah.
reliability, load balancing. And most of our code is there.
Okay.
The file where Autoscaler lives is called autoscaler.cpp. That's simple.
And is this in the latest drop on the GitHub repo?
Yep, it's available since 6.3, so it is.
Perfect.
This summer.
It is
Perfect.
there.
Great.
Yep.
So go check it out, people.
Yep, go check it out. It's not that complicated, this file, either. So what it does, it has two main routines, which are called process partition or process service, because there is another type of autoscaling that we will mention a little bit later. And when we are processing partitions, what we're gonna look is we're gonna have a list of all partitions that should be autoscaled, right? And each time we wake up, and our thread wakes up once every second, we're gonna know which, based on time counters, we're gonna know which partitions we need to look at. So we will look at this partition of your service. We are going to look at the average load of your all instances, and then we're gonna check the conditions that you specified in the trigger here, right? So if your load is either smaller or larger, we invoke the mechanism, okay? And let's say that your load is larger, that you reported like 80 here instead of 20.
Sure.
Okay? What happens then is that we actually need to change the description of this service,
Okay.
right, and of this particular partition. So for that, we will actually send a message to our failover manager, which is collocated in the same process with us. And our autoscaler will send a message to failover manager saying change target replica count or target instance count. So in this case, it changes from 1 to 2. Okay? And then we follow the usual process for placing new replicas.
Sure.
right? Which I think
True.
Young explained
Yeah, he did, yeah.
in
Sure.
some detail last
He did.
time. So, and then we don't do anything for this partition for the next 60 seconds.
So you wait to calculate it and see if adding a new made a difference to the average, basically.
Basically. So we don't do anything in the autoscaler. You can still report load. Load is going to arrive, it's going to be persisted, but we won't be looking at it
Until this interval.
and this interval expires. Right? This is a way to actually protect you from creating kind of ping pong effect.
Sure.
Right? Because if we do it every second, we can just keep adding, removing things.
So what is your expected sort of relationship between when somebody should be reporting load versus the interval? Do you want that to be, multiple reports per interval? Do you want it aligned with the interval? Like, what would be in your world? What would you recommend?
Actually, depends it depends on the nature of your workload. Even if you do report too often, what we're going to do on this side is we're going to do some load smoothing, right? So we won't be sending each and every individual load report. I mean, it really depends on how dynamic your workload is,
Sure.
right?
And so out of
And
curiosity.
from my experience, excuse me for
Sure,
interrupting.
no worries.
Most of our customers actually report once per interval,
Okay.
once per load reporting interval, which is usually every 15 seconds.
Okay,
If the load is dynamic, if the load's static, then they don't report at all.
interesting.
And I would also actually encourage a bit more frequent load updates, like not every 10 minutes, but once every minute or once every 30 seconds, because these are actually one-way messages. They can get lost.
Right.
They're
Fair
not
enough.
reliable. They're not
Is that what you're
reliable.
gonna ask?
So it's not reliable transport.
No, in this case, no.
So, but I mean, from the developer's perspective, the implementation of sending a load report, is it equivalent in sort of concept to sending a health report?
Yes.
Okay, so developers have to be sort of cognizant that they need to do this.
Yes.
Versus it being an automatic thing where Fabric.exe or some subsystem component sends out load reports based on what it's understanding from resource monitoring and PLB.
Yep.
So that's going to be the other autoscale that you're going to talk about.
That's gonna be up the resource monitoring service. But
Okay.
we also do have one more
Great.
type of autoscale,
Okay.
right, which I'd like to mention. So this one was adding or removing instances, right? What we can do is we can also add or remove named partitions. Like, so if you want to have a multi-partition service, then pretty much trigger is the same. And mechanism, just instead of instance, you say partition here. And in that case, mechanism is the same. Load reporting mechanism is the same as this one. You send load reports for multiple partitions here. When Autoscaler wakes up, it looks at the average load of all partitions that you have, and then decides whether it needs to add one more partition or to remove one of the existing partitions. So it basically invokes repartitioning operation that goes to our failover manager. So this one can be a little bit dangerous. You really need to know what you're doing if you want to use add remove name partition. Because if we scale down, we're just going to delete the partition. You don't get any warning.
That's interesting.
Yes, if you have any data in it,
Gone.
gone.
So how do you protect against that as a developer?
In this case,
Why not set a lower bound that's never going to be hit?
oh, you can set a lower bound that's never going to be hit here.
Yeah.
That's not a problem. We'll never go below 2 partitions, right? But if you have 3 and we scale you down to 2, you lose data.
But what about your trigger? So set a trigger that will never be hit at the lower end.
You can do that as well.
Why not use that as a way to never...
Then you will only scale up
Yeah. That's not
and
bad.
never scale down.
Yeah, but that
can
way
do
you're
that
never
if you
losing
want.
partitions.
You're
and
very
only-
positive.
Huh?
You're a very positive developer.
Yeah.
Only scale up.
Only scale up.
Yeah.
Only scale up.
Yes.
Well, I mean, it's dangerous with stateful workloads.
It is dangerous.
You stuff data in there and you're never getting it back because we're writing directly to the log file on the machine.
Sure.
Once we wipe that, there's no recovering that.
No?
But let me ask you a question. This sort of flies in the face of the primary, sort of the prime directive of Service Fabric, and that is, we will not lose your data. We will not lose your data. Right? That's like our prime directive.
Unless you do
Unless you do something stupid.
this type of auto-scaling that I just mentioned.
But why do we allow for that type of auto-scaling if in fact it can be in sort of contrast and contradiction to our prime directive? Like what's the benefit?
People asked for it.
They did?
There-
Like
there-
with
there are
SQL
some-
and.
There are some
of
use
course.
cases.
Cosmos DB, of course. Okay,
Yeah, not SQL, not Cosmos DB,
But somebody.
Somebody asked for it, yes.
okay, fair enough. So, perfect. I just wanted to ask that question because.
Yeah, that's a valid question. The second type is dangerous. You
Okay.
can lose data.
So this
There is a big nice warning on documentation page as well that says the
says you
same
might lose
thing.
data.
Cool.
Yep, you may lose data.
This is a fascinating one though, because this means that if I have a stateful service that is, let's even do something really basic. Suppose I've got user data coming in for a website where people are signing up, and I'm partitioning. I don't know what would be a partitioning scheme that would evolve. Whatever number of people that are currently stored in a partition, for example, something very trivial where I'm going to keep adding partitions for every X number of people that sign up for this service. And let's do the thing where I never go down. So I'm only doing up. My stateful service itself actually has a preset number of expected replicas. All you're doing is adding a new partition. So that way you're actually maximizing your juice like quite well in your system. You're running relatively densely there because what you're saying is that I'm already having the number of replicas that gives me the level of comfort for how many times my data is replicated and I'm happy with it. So I'm not like losing things because of chaos in the system or other issues at the infrastructure level. But I'm just adding, another partition to each of those replicas basically now and giving it a new set of 5 or 9 or whatever I went for, which is pretty cool. But yeah, like you said, there's always a downside.
There's a downside. I mean, this is very dangerous with stateful persisted. Like, you want to build stateful volatile service as a cache, this can
That's
actually
fine.
be useful.
Yeah,
You can scale up or down your cache based on the demand.
that's interesting.
Cool.
So that could be a nice use case for this.
Well, yeah, on the note of
and it's volatile. You lose partition, you can always rehydrate data from somewhere.
in the case of stateful persisted though.
Like, stateful persisted is dangerous.
No, but-
Don't use.
Well, you've got an interval, fine. So even the other one, you've got an interval. When we replicate stuff, we're physically copying things over to secondary replicas.
Yes.
Yeah. What happens if the data package is large enough that it eclipses the interval for how long it takes to scale up? So for example, I hit my upper trigger. It takes me 70 seconds to actually stand up a new. And here I'm talking about instances, I guess, or replicas, not really partitions. So 70 seconds to create a new replica of a service. The interval is 60 seconds, so I'm always catching up.
Depends. So in our case also inbuilt replicas, so this one that's being built can have load. So it actually depends on what's the load of the inbuilt
Oh,
replica.
we calculate that in the
We
average?
calculate that in the average.
I see.
So in this case, if you're starting with 0, it's gonna bring your average down.
Because it's going to be a 0 there.
It's gonna be a 0
So it
there.
does anticipate in some way that even if your system is lagging, you're probably still getting the right amount of scale. You're not accidentally overdoing it.
Yep.
Okay,
Interesting.
so let's dig a little bit more into that box in the resource monitoring side.
Okay, so
Unless there's any more nuggets that, Actually, one question I do have is, this sort of looks exactly how it looks in the JSON or the YAML
Yes.
format for mesh applications.
I may wrote something.
Yeah, but it's almost identical
It's
to
almost
this.
identical.
What about implementing this if I'm a current service fabric user, I've been a user for a while, I have my cluster, I'm using an app manifest.xml and a service manifest.xml. Can I add this? Is there?
You can do whatever you want. You can add that, you can update your service with these policies, right? You don't need to do an upgrade.
Okay.
So in order to change auto-scaling, you actually don't need that upgrade, which is a good thing.
Cool.
So you just call update service and you give new policies either in PowerShell, REST, whatever you like.
Okay.
So any mechanism that we support for updating service, you can also use it to change the autoscale.
Great.
That's pretty neat.
Okay, so now back to actually monitoring. So to To your question from before,
Yeah.
if you don't want to do all this, right, or if you have legacy code, guest.exe, container, whatever it is, where you're not even able to do it, so you cannot change your source code, we can actually monitor the resource consumption for you. So what we do for that is we add a small new service to the node, which is called the resource monitoring service. And it's enabled by a cluster manifest. It is an add-on feature, pretty much in the same way in which we have DNS service. I don't know if you have a video on it.
Yeah.
We don't, not a DNS service.
Not yet, but
Okay.
we've talked. I mean, I think people are familiar with it, or we'll
sure.
have one at some point, I'm sure.
So it's add-on feature. It's a stateless -1 service. That means it's going to live on every node in the cluster, and it's pretty lightweight. Doesn't do much, right? Doesn't do any serious computation. What it does is, so every time one replica is opening on the node, right? It gets information from a reconfiguration agent, gets a message saying, I am opening a replica, and this is the host that's going to be hosting it, and this is the partition ID of the replica that's going to live inside. From hosting, it'll get a message saying I have opened this host with this process ID, or with this container name, or whatever it is.
Sure.
Right, anything that we need to
Unique
monitor.
identifier, basically.
Right, there's one catch and there's one limit to what resource monitoring can do. So I don't know if you guys had a video on activation modes, shared and exclusive.
Yeah,
Yes.
we did. We talked
Yes,
about
we
it with
have.
our hosting
Good.
folks.
So, for scaling purposes, what we need to do is we need to associate the load with the partition, right? And if you have multiple partitions in a host, then that's not possible to do. So currently what we do is we support only monitoring of exclusive activations.
So exclusive process
Yes.
model, yes.
Exclusive process model.
So each service runs in its own process.
Or container.
Got it. Understood.
So we pick these two things up, right?
Mhm.
And this guy also has a very simple loop inside, very simple thread. Wakes up very frequently, and there are things that you can configure as a user, but these are really, really advanced. So we didn't want to put too much pressure on our system, on our hosting, and on Docker on the node, or whatever container runtime there is. So I think defaults are order of tenths of seconds,
Okay.
where we measure things. So like every 10 seconds, we're gonna send a message to Docker in case of container asking, give me stats
Yeah.
on this container. We take CPU, we take memory, and we do some basic load smoothing here as well, so that we eliminate short-lived spikes. And we send it as a load report in the same way in which we are sending the regular load reports.
But this is key though, because this means, like you were pointing out earlier, Charles, that a developer needs to take action. If they actually go via this path, they don't actually have to take action. As long as they're specifying CPU or memory as
Yeah.
their chosen
So,
metric, they don't actually have to write code to do this. It's just
Sure.
a config change.
Another thing that I forgot actually to mention here in auto-scaling definition, you need to say which metric we need to look at. So in this case, it was number of connections.
Yes.
And you can say CPU, for example. Actually, the name is a bit
Is
longer.
that like percentage processor time or something like
No,
that?
this is number of cores.
Number of
so
cores,
we do
okay.
everything in number of cores.
Okay.
And so the default mitigation, I'm not gonna say mitigation, the default action is for you to auto-scale, right? So in other words, what I'm saying is, if over n amount of time, the CPU is at 1%, I wanna scale down. Or if memory is at like some really low value, right? It's not just about connections. I might wanna go into a little hibernation state and then come back up.
Percentages are a tricky thing to express here,
Okay.
because percentage is always a percentage of something, right? And if it's percentage of a full machine, then you need to know in advance whether this is going to be open on a node with 4 cores, 8 cores, 64 or 128 cores.
Okay.
Right? 1% is not the same thing.
Amen. I get
So-
understood. So forget about the actual fact that it's a
Yeah.
double. I was just talking about,
If you give a 0.01, we'll always assume that this is 0.01 cores or 1% of a single core.
okay,
That's what 1% means to us.
Okay, great.
Okay?
so it's per core.
Yeah, it's per core. So whatever Docker returns in terms of times, like user time, kernel time, whatever it is,
Yeah.
then we're gonna transform it into a number like this.
Great.
So we use container runtime interface to query container usages, be it on Linux or on Windows. On Windows, we use job objects to query the usage, and on Linux, we use cgroups, right? So we make sure when opening processes that everything is either in a job object or in a cgroup, depending on the operating system, and then we exploit that fact to actually measure. So we get measurements from the OS free of charge,
Okay.
in this case. Yep, and that's pretty much it. So it's not too complicated as a service, this one.
Right.
And it
But
shouldn't
that's
be.
by design. That's by design.
That's by design. It's not allowed to use too many resources.
Otherwise, we'll clog the system with our stuff, and then there's no room left for
No,
user
you're
apps.
right.
Yeah.
Agreed.
You're right.
Agreed. I mean, I can think of a operating system does that really well.
Aha, funny.
So, what now? One of the things that's important to a lot of people is I/O, right? And disk. Like, how much disk space do I have? Give you a percentage and say, if I reach 70% disk space, I know something's wrong because we should never be that high. Like, I might have my own understanding of what my service does. Or I might be able to say, hey, auto-scaling system. It's okay if you find that all of my processors are cranking at 95% for the next hour. That's killer. So if it's, because what I'm doing is actually computationally intensive. I don't want anybody messing around with saying, oh, we need to do this, we need to do that. I might already know what I need to do, and I don't want you to get in the way, even though you're super helpful. So I guess you could say, well, then don't create this.
It's a simple and very fast call to turn this off whenever you want.
Okay. And what is that?
Update service. Do you remove the policy?
Got it.
Do you only remember what the policy was if you want to put it back again?
Okay.
Then you do another update service call. It's very fast.
I'm sure it is.
Yeah, update service propagates to the cluster way faster than an upgrade.
Than an upgrade,
Yeah,
definitely.
correct. Because it doesn't do the UD walk, it just instantly changes the configuration.
The UD walk. What's
I love
that?
I love that phrase.
Right on.
UD walk. That also means that you can automate autoscale. So you can programmatically automate autoscale and set up autoscale
Yes.
for your cluster,
Definitely.
Yeah.
right?
Absolutely.
Because I could have a autoscale manager service that decides when to turn my autoscale on and off automatically.
Yes.
And then autoscale would kick in automatically. Instead of
That's
autoscale.
great. I like it.
That's actually not a bad idea for some people that might have the requirements that you're saying, which
Sure.
is I have to
Somebody-
dynamically adjust my ability to do things.
But look, this is sort of the power of Service Fabric, right? Service Fabric is a lot like C++. You're given all kinds of power.
Yeah, you just need to make sure you
You just need to understand,
Yeah.
like, be thoughtful about, I'm doing the right thing, I'm not going to kill myself. But we let you do everything.
Stateful persistent partitions.
I think that's a good lesson. That's a good takeaway from this.
Yeah.
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 Let's say that one more time. Ready?
Don't autoscale stateful persistent partitions.
Thank you.
It's almost like a tongue twister.
Can you say that really fast, 10 times?
Do not escape state for persistent topic.
Okay.
I can't.
Yeah,
The point
that's
is-
a hard one.
I don't even want to try.
Please
Yeah.
remember that, people.
Yeah.
Yeah.
Cool.
So let's springboard this conversation into one of my favorite topics, because I hear this a bunch from people.
Okay.
Resource governance. So we've done a little bit of conversation about it in these videos as well, but it still comes up all the time. And it's very relevant in this world, especially the kinds of questions you're asking, Charles, where you're like, am I looking at percentages or absolute values? And that I'm immediately thinking about the resource governance service, and I know that you're, well, it's not a service, this is resource governance is a concept, and you're an expert in that. So I'd love to hear a little bit more, and I think we all would appreciate.
So,
Take it away. You know what I'm gonna say.
Yep. So, and now we also change the folder a little bit. So we're no longer in load balancing, not even reliability. So, resource governance is kind of orthogonal to Autoscale, but it also plays nicely with Autoscale. So,
Okay.
with resource governance, what you can do is you can actually say that whatever you activate on this node is not allowed to consume more than 2 cores and 1 gig, right? And by whatever you activate, I mean service package. So I'm assuming you guys had a video on service packages.
Yeah, we talked about
Yes.
put back to service
Activations,
packages,
yeah. So when governing things, then you need to govern always the thing that gets started, right? So it's not possible to govern a replica, right? Because when you start a single replica on the node, what hosting is gonna do, it's gonna bring up the entire service package with all exes, and we want to put limit on that.
Okay.
So when expressing resource governance, when you're writing your service manifest, then so I don't remember the exact syntax, so please look it up in our docs if
Sure.
you want to see it. So you can say things like this service package, so service package 1 for example, is allowed to consume at max 2 cores and 1 gig of RAM. Okay? And if you use exclusive activation model, exclusive process, then this basically translates to replica uses 2 cores, 1 gig. If you're using shared, then all replicas are using 2 cores and 1 gig. And if you're using container, then your container is using 2 cores and 1 gig of memory.
Sure.
Okay? So this is how you describe it as a user. Okay? And this required some changes in the load balancing component that we have, because prior to introducing resource governance, we always had the notion that the load is on partition level. So this here is partition, right? With this, we had to introduce the concept of a load on service package level. So prior to this, PLB didn't know much about service packages. And with this change, what we had to do is we actually had to start receiving information from rest of the system through failover manager about service package as well. So then suddenly we also need to know all the descriptions of all the service packages that we have. And then the logic that we use for bookkeeping for our loads. So imagine you want to place a replica on a node, right? If it doesn't have any resource governance, that's easy. It carries its own load, right, on any of your metrics that you have. And if it does have resource governance, then when choosing the node, so for example, if this is one node, this is the other node, and they both have 4 CPUs available, right? And we want to place one more replica of this service, then if this node here is empty, then this new replica actually would bring 2 cores, right? But if there is one replica from the same service package on this node, then this new replica brings 0 load, right? So that's a bit of additional complexity that we introduced in the load balancer for this.
Oh, that's a bit weird. Yeah, it makes sense.
It does. I mean, we're limited by what we activate, right? So you need to govern what we.
So what happens if there's something that doesn't actually have resource governance turned on for it? Does that change the way you make any decisions in that case? No, right? Because then you're just going based on what PLB is calculating for
regularly,
what can be
yes.
placed. Yeah.
Yep.
So the question I have is, it's one thing to measure how much a process is using, for example, in the exclusive case.
Yep.
But what do you actually do when they get to that threshold from what do you do? So
Depends. So when we actually activate the package on the node, in case of Windows and in case of processes, what we do is we put it in a job object, right?
Yes.
And we calculate the correct CPU rate, and we calculate the memory limit, and we set it on the job object.
And Windows controls.
Windows controls that.
So I guess my question is, what's the side effect of when I reach
Side
that
effect
threshold?
Depends.
Okay.
CPU, you're just scheduled out
Okay.
when you reach it, during the scheduling interval by the Windows scheduler.
Okay.
Same in Linux, right? We'll put you in a C group, we're gonna set period and quota so that you get 2 cores equivalent on the machine. Once you reach your quota during the scheduling period, you're out.
Interesting.
So you're basically throttled for CPU. Memory, on Linux, what we do is we put a limit on the amount of RAM that's available to you. Once you reach it, the OS will start to swap you out. Right, so you're not allowed to use more RAM than that. Same on Windows, and on Windows there is also a mode where you can get out of memory.
Okay.
And now, strange thing is, if you ask for this, so currently we don't support regular limit reservation, but we treat this both as a limit and a reservation. So you're always going to have 2 cores available. If you don't want to use them, don't use them. If you want 3, you can't. Okay? And to support this, so aside from changes in the load balancer, also on the node, we had to add a kind of mini load balancer. So, and this one is called local resource monitor, right? And we inserted it into the path for opening, meaning activating or deactivating service packages on the node. So every time hosting wants to activate, it's going to send request to this one, asking us to calculate correctly and to create job object or C group or whatever it is. And here is also where we protect ourselves in case that it could happen that some messages don't arrive in time. So PLB thinks there is space, but there's actually none, right? So we actually won't be allowing the code package to open in that case, right? The service package to open. But those situations are transient, right? We had to protect from them because usually when you as user ask us for 2 cores, you want them all the time, right? You don't want someone coming asking for entire node, we give it to them, and then for a little while you get.
It also sounds like, I want to come back to Autoscale unless there's anything else you want to bring up on the implementation for... Yeah. So you talked about CPU and memory being built in, and then we have the ability to report our own thing. So this is all fine and dandy in a service array cluster where I own the cluster and I can report into PLB.
Okay.
With Mesh, it's not so dandy, because Mesh, you can't just pull up your client APIs and be like, hey, PLB, here's what I'm telling you. That's not something we want people to think about. So what does this look like in the future for where I'm somebody who's building a website or a gateway service on Mesh instead of service fabric clusters? I want more than just CPU and memory. That's a hard problem to solve.
It is. In future, we will be adding new capabilities to Autoscale, definitely.
So is that going to be like a controlled set of metrics then, or are you going to come up with a way that we have an anonymized balancing framework or something where?
That we still need to decide.
Okay.
So adding control sets of metrics most likely is going to happen. Like
quite easier too.
Yeah, scaling based on network or scaling based on
QDepth, that's a popular one.
There is a popular one definitely, or scaling based on some external triggers.
Sure.
That's a popular demand. Scaling on custom metric in Mesh, our implementation is there. Basically, it depends on the timeline of when we will add support for regular service fabric apps in Mesh. So
sure.
the moment you're able to report load, meaning the moment you're able to deploy a regular SF app into Mesh, this just works. All
Yeah.
works.
So I'm gonna bring this back now.
Let's bring it back to
last couple
reality.
of minutes. So,
Okay.
The first time Charles, you and I did a video.
Yes.
The first comment we ever got on that video.
Yes.
What you know what it was? What does SF team do in Serbia?
Yes, that's
That
right.
was the first comment we ever got on a video that we've done together for Service Fabric.
Yeah.
And now we actually have somebody from the team. So you come and visit us, you know, fairly often, every couple of months or so. We finally have you on camera. What do you do in Serbia? Tell us about the life, something more interesting than, you know, PLB.
What do you want to hear?
How's the culture like? How does it differ from what it is here?
I mean, culture, in a way, is similar. So, team in Serbia is young, very good people. So, because the team here is also young, then the
Very
cultures are, and with very good people, then the cultures are very similar. I mean, Serbia is a nice place, right? There is Microsoft Development Center there, which is mostly doing Azure data things.
Right.
And Service Fabric is, what, 9 of us now, I think?
Wow.
Something like that. So it's smaller part of the center, right? But we did manage to get ourselves into the heart.
I mean, you guys have
Of
made a
Service
big
Fabric.
difference.
For sure.
Yeah, some of the
Right.
key
PLB
stuff.
is critical. I mean,
Super.
Yeah. I mean, most of the things that we do, which is really cool,
Yeah.
is they are on a critical path, right? So if this one here doesn't work, your replica is not open, right? If PLB is not working, your service doesn't get placed. And somehow we like to do stuff like that, right?
Sure.
Brings adrenaline.
Yeah. Especially
It's
when we
cool.
were a remote team coordinating on things like this. It's definitely been fun.
Yeah, and I mean, remote team, there were no major problems with
That's good.
communication.
I'm glad.
Because some of the people that we collaborate with, they get up very early. So we used to have 7 a.m. meetings at one time, which is 4 p.m. Serbia time, which is not bad.
But I've been on the phone with you at some fun times.
You've been on the phone with us.
2 in the morning Pacific, 2 in the morning Serbian. We trade on and off.
Yeah. there was a nice period.
Hey, all in 6-4. Now that it's out, it's out. We're good.
that's great.
And then talk to me about this T-shirt, because most of us, I've never seen it before.
I did. I saw it in build.
No, actually, you didn't.
This was
This
the
is
build one?
custom Serbia one.
It's
Hold on.
They
hold on.
customized my custom one.
Yeah, there are no changes.
Oh, well, but it was printed in
Yeah.
Serbia.
Was printed in Serbia. Has, I think, Microsoft Development Center Serbia written on the back.
Cool.
So what you don't have, it's different color.
Yeah, it is a different color,
Yeah.
and the logo is blown up.
Nice.
Yeah, so Nikola was here for build. He
Yeah.
saw some of the T-shirts that I had made, the ones with the smaller figure. I sent him the file, and then next thing I know, I see him. He sends me an email with a photo of this, and next time I see him, he's got one of them on. That's pretty awesome.
Nice, man.
Yeah, carving out your own community there as well, which is pretty cool. Hopefully one day we'll get to visit. Pay you the favor.
Why don't you come and take some videos in Serbia?
Yeah, there you go.
So you get to film more team members.
Absolutely.
We'd love to. So with that, signature question time.
Okay.
If you had one piece of advice you could give to anybody about anything in the world, anything at all, what would it be?
Okay, I didn't prepare for this one.
That's the
point.
idea.
That's the point. To anybody about anything, take it easy. Would be advice.
Cool.
Definitely.
Good. That's great advice.
Just
Right
take
on.
it easy.
Take it easy.
Whatever you're doing, take it easy.
Cool.
Thank you so much for your time.
Thank you
Nikola.
so much,
Thank you,
man.
guys.
Very useful. You guys do great work there.
Yeah.
Check out their code, people.
Yeah, check out our code
And
and come visit Serbia as well.
And come
If
visit
you're
Serbia.
around.
Absolutely.
pay him a visit.
Okay, guys.
Yeah. All right.
And were you going to do this again?
Yeah, I think so.
Probably not before the end of
I
the
don't
year.
know about the end of the year. We'll try.
Okay.
But probably not. We've got a couple conferences coming up, and then people want to go home for the holidays. But
Amen.
Soon enough, you will see us again.
Right on.
All right.
Cool.
Cheers.
Take care,
Thank you so
guys.
much.
Okay.